everyone. I'm the TA for this session, Newton Mechanics with Newtonian Mechanics with example. So I'm PhD student at IIT Delhi and University of Queensland. So today is class for week 6, and we are gonna discuss some conservative force problem, projectile motion problem, and some rocket problem. So let's begin. So for conservative force, curl of F becomes 0. Conservative force means that it depends only on the initial point and final point. On the path. So for that kind of force is basically gradient of a potential V, negative gradient. That means the direction of a force is opposite to the potential energy. So work done by the conservative force. Okay. So curl of F should be 0. How we can say that? Like when we take some conservative force and to curl, that is 0, because basically curl of any gradient should be 0. If it is a conservative force, then force is equal to gradient of potential energy. So that's why and now if a force is conservative force, it is always a gradient of some potential. So curl of a gradient is always 0. So if we want to know like which if the force is conservative, we simply tends to like follow this rule and to the curl. So some of the conservative force are gravitation, electrical force, and so such. And another thing is the round trip work in round trip under conservative is 0. So basically that means F dot dr is equal to 0. Some examples are gravitational force, elastic forces, so now move on. Some problems with conservative force. Okay. This is basically a vector problems. First problem is F is given x cube minus 4x y square plus 2i plus 6x minus 7y plus x cube y cube j. Determine if the force is conservative. So curl of F should be 0. So first determine curl of F. So ij although there is no z component here, but to determine the curl we need to write this z component. Okay, so basically when we want to compute I component, so del y 0 is 0 minus del z of 6x minus 7y plus x cube minus y cube. There is no z variable, so that will be 0. Same for j, it will be 0. Only the k component or z component will survive. So what will that be? Del x 6x minus 7y plus x cube y cube minus del y x cube minus 4xy square plus 2. Okay, so this will be 6, this is 0 plus y cube 3x square minus 0 minus 4x into 2y. So this is basically 6 plus 3x square y plus 8xy. So clearly that is not equal to 0. So this f is not a conservative force. Let us see if another problem is the force in the another problem is conservative or not. So we need to obtain curl of f. Basically, E, J, K. Similarly, like to the previous problem, the K or Z component survive. K will be 2 minus 6xy plus 2x square cos 2y minus del ly 2x sin 2y minus 3y square. This will be minus 6y plus 4x cos 2y, and this is will be 2x cos 2y into 2, because here there is the y has a coefficient 2, which is 2y. So k is minus 6y plus 4x cos 2y minus 4x cos 2y plus 6y. this is equal to 0. So this force is negative force. Okay. Then I want to also tell you I didn't get any problems. Maybe in next class I can discuss some problem with conservative force in another coordinates. But let us tell me uh, that what are the gradient, divergence, and Carl formula in general in any coordinate, and then you can put the scale factors and coordinate in the place, and you can have a gradient, Carl, and divergence formula in respective coordinates. So let us assume E1, E2, E3 are the coordinates, and H1, H2, H3 are the scale factors of those coordinate. Assume R is position vector. Any vector. So basically H1 means del R1, not R1, E1. Not yeah, E1, E2, and E3. Basically U1, U2, and U3 are the coordinates, unit vectors. E2 and E3. Basically H1 is del R1, del R, del E1. H2 is del R, del U2, and R, del U3. So, in most general formula for gradient, we need to know the what is the role of the gradient. Gradient acts on a scalar field and give us a vector field, and its physical significance we can discuss it. This is not the scope we of the lecture here. So if you want me to discuss the physical significance and how we derive this equation, let me know that, and maybe I can discuss that in the extra class. So it is basically H1 del phi, which is the potential here, U1 E1 1 by H2 del phi del U2 E2 1 by H3 del phi del U3 U3. Okay, and let me write the gradient formula. So This is the gradient. Gradient acts on a scalar and gradient acts on a vector field and give us a scalar field. So this is the thing. So the gradient formula is this: del del u1 h2 h3 a1 plus del del u2 h3 h1 a2 plus del del u3 h1 h2 a3. Remember here there is u1, here you will not written h1, u2 there is no h2, u3 there is no h3. The Carl formula is this: 1 by h1 h2 h3 h1 e1 h2 e2 h3 e3 del del u1 h2 a2 del del u3 h3 a3. So for Cartesian coordinate, h1 h2 and h3 all are 1. So and e1 is I, e2 is j, and e3 is k. U1 is x, u2 is y, u3 is z. So gradient formula became del del xi plus del del phi phi j plus del del phi del z k. But for cylindrical coordinate, u1 is rho, u2 is phi, u3 is z, h1 is 1, h2 is rho, hz is 1, h3. And here x, if we want to write x, the relation between x and this cylindrical coordinate is rho cos phi, and y is rho sin phi, z is z. So gradient will be here del del rho phi rho cap plus 1 by rho del del phi. Sorry, okay. Here we can use another like angle which is theta. Theta phi theta cap del del z z cap. For spherical coordinate, now when you are given a scalar field and you were told that give us a vector field, corresponding vector field in cylindrical coordinate, just put the phi and also phi will be in terms of here, phi will be given in terms of rho, theta and z. Just put it in the thing and you will get the vector field for spherical coordinate u1 equal to r, u2 is equal to theta, u3 is equal to phi. I will here, let us assume that it is not like scalar field is not phi, it is another thing, otherwise we will get confused. So basically we can say it phi dash. So for that it will be del phi dash del r cap plus 1 by r. Oh, let me tell you what are the h1 is 1, h2 is equal to r, h3 is equal to r sine theta. Del phi dash del theta theta cap plus 1 by r sine theta del phi dash del phi cap. Many other different coordinates, and for those coordinates you will get respective h1 h2 and h3, and when you use those h1 h2 h3 you will get the result. Similarly, when you put h1 h2 h3 here, like for cylindrical coordinate, let me write it. Will be 1 by rho del rho. H2 and H3 here is 1, here A1 plus del theta. H3 is 1. Okay, H2 is here is, oh sorry, here we need to put a row because of H2, and H3 and H1 is 1, so it will be only A2, and del Z, H2 is rho and A3. Spherical, let me write the spherical coordinate. Okay, we can write this as also this 1 by rho del rho A1 by del rho plus 1 by rho del A2 by del theta plus 1 by rho. Here in rho, here we are doing differentiation, partial differentiation with respect to z, so we can like put the row outside the differentiation. So del A3 by del Z. So this row and this row will cancel out. The spherical coordinate will be 1 by r into r sine theta. Here it is r cap, r theta cap, r sine theta, phi cap. This is del del r, del del theta, del del phi. Here only A1, here will be RA2, R sine theta, A3. This is basically R square. When you like expand this thing, del theta R sine theta A3 minus del del phi RA2 R cap here will be del R R sine theta A3 minus del del phi A1 theta cap plus del del R RA2 minus del del theta A1 theta phi cap. So when you put these things, you will get the conservative field and all those things. Spherical coordinate is very important as most of the central all the central force are function of in spherical coordinate. Now resume to the like another type of problem. The force is given 10 the potential. So is given like this. So the force is within a bracket and a comma. It can be given like this also. Not J. This is I basically. X plus 2xy minus 2yj. So first step, please, I want to discuss only one problem about it. And please understand these things. Even if you don't get involved this kind of problem in Newtonian mechanics, like in conservative force problem, you need to like solve this kind of question. But even if you don't face such kind of question is direct mechanics problem, you could get that in vector analysis and any other other subject of physics. So first we need to step 1 determine if the force is conservative or not. Okay, so basically to determine the force is conservative or not, see, we have done some questions. What we have basically done, so we took the curl. So by taking care of curl, we take x derivative of this z component thing. When there is not z component, we take x derivative of z component and y derivative of x component. So basically, to know if the force is conservative or not, we don't need, for this kind of question, we don't need to give very good explanation of whether it is conservative or not. For your information, you should know whether the force is conservative or not. So we want to do the curl thing very quickly. So what happened? We will check del x of sine x plus 2xy minus 2y minus del y cos x plus y square. So we will see if this thing is 0 or not. So sin x is cos x plus 2y, derivative of 2y is 0, minus, here it will be cos x plus 2y. So basically it is 0, the force is conservative. So next comes the second part or step 2. So force is conservative when force is conservative, then force is potential. So that means del v del x, we will like consider the minus sign at the end, del v del y, as there is no z component like x y z component, we are taking del v del x del v del y only, and it is y cos x plus y square minus in comma sin x plus 2xy minus y. So basically del v del x is y cos x. Oh, this is step 2. Cos x plus y square. Del v del y is sin x plus 2xy minus 2y. Now you can take this thing, step 3. You can take del v del x and something here. You will get v with obtaining something dx with c. Now you can, like, you also have a del v del y, right? So basically what you can do, you can like take that del v del y and equate that v function of x and y and equate with del v del y what we have and obtain the unknown c, or we can have del v del y, then vxy will be some integration into dy and you will get something here, and we need to like equate those things and obtain c. Or you can do that, you do first here the del v del y, we get the c, then like differentiate it x with x, then equate with that and obtain c. You can do this in 3 ways. Let me like give you an example where I'll do it in a first way. Everywhere will give you the same answer, same constant value you will get at the end of this thing. Del v del x is basically y cos x plus y square. So when x, so this will be sin x plus y square x plus c. Now this is a constant and we know v is a function of c is constant with respect to x, but it's a function of both x and y. So y is a form of c is a form of y, and del c by del x is 0. Now to obtain the y, what we need to know that v is equal to y sin x plus y square x plus c y. So del v del y sin x plus 2xy plus dc by dy. Okay, and we have a y value here, which is sin x plus 2xy minus 2y. So dc by dy is equal to minus 2y. So c will be minus square a. K will be constant, some constant, which is not a function of x and y, and we can say that it is zero kind of thing. So ultimately dx would be y sine x plus y square x minus y square. So let me write it del v dash. So v dash will be minus y sine x minus y square x plus y square. This is the potential you will get. Now another type of question is here. dr where if y is equal to 2y e to the power xy plus 2x e to the power x square square I plus 2x e to the power xy minus 2y e to the power x square minus y square g, and c is the curve shown below. So here you can see that we need to like do the integration with respect to c. One, two, three, four, five. This one, this two. So the curve is like this. This is 3 comma 2. So the path is like this. Okay. So first of all, we won't do this all kind of thing like intuition from this point. The first point is here 1 comma 1 comma 2 comma 0, and like we will take a slow find a function between x and y, all those things. We can all do that, but the easiest way is like this. First, calculate the force is conservative force. So if curl of f 0 or not. So again we need to know that if this is this value basically. So that would be 2 e to the power xy plus 2x e to the power xy into y minus 2y to the power x square minus y square into 2x. It will be 2 e to the power xy plus 2xy e to the power xy minus 2x e to the power x square minus y square into minus plus minus 2y. So we can see that this crosses this crosses this, and this is minus. So this crosses this. The conservative force. If this is a conservative force, it is del V something. So basically F dot dr will be V endpoint minus V start point. Now, like the previous problem, we'll obtain V. Now we can do this thing otherwise, that we can take del f del y. Del y is equal to 2x e to the power xy minus 2y to the power x square minus y square dy. So phi will be dy. So that will be 2x e to the power xy by x minus y e to the power x square minus y square y minus 2y plus c. So this will be 2 to the power xy plus e to the power x square minus y square plus c. Then we will obtain a del v del x, which will be 2y to the power xy plus, and c will be the function of x, 2x e to the power x square minus y square plus gx. So dgx by dx, comparing it with our dv dx, it is z. So gx will be c. So vxy, we get 2exy plus e to the power x square minus y square plus c. Point when we write v in point minus v start point, if we take in consideration the minus sign, we will get the same thing eventually. So basically v5 comma 0 is the final point minus f0 comma 1. 0 comma 1, this is 5 comma 0, and what we have updated, if that will take care of all this like line. Okay, so that will be 2 plus e to 5 plus 25c minus 2 plus minus 1 plus c. So that will be e to the power 25 plus e inverse. Plus this will be minus. So this is the answer. This is the work done under the F along the path C. Now let us get into some projectile motion problem. For projectile motion, we need to remember the basic like equation here will be v minus ugt is equal to u square plus 2gs or minus, and h is equal to ut plus half of gt square. And these equations, with there will be an x component and there will be an y component. So basically g works in the y direction, in x direction there is no g. So basically remember these equations. Start with the first question. Stone horizontally at a speed of 5 meter per second from the top of a cliff that is 78.4 meter high. How long does it take the stone to reach the bottom of the cliff? How far from the base of the cliff does the stone hit the ground? What are the horizontal, vertical components of the stone's velocity just before it hits the ground? So basically, this is the cliff. This is 78.4 meter high, and the horizontal component of velocity, that is v, is 5 meter per second. So we need to obtain the time t. This is how much we have that has gone, and what was Vx and Vy at uh, first we need to obtain the t. So out of all this question, either we can use this or this to obtain t. To obtain this, we need true velocity. We don't have that, so we will go with this thing. We need have the height. Okay, the velocity of x is given. There is no mention of velocity of y. That moment call it v dash x vy dash. So vy is 0. So y, which is 78.4 meter, is equal to vy minus half of gt square. So y is equal to minus half of gt square. So E is equal to minus 2yg. Training. So the distance will be there minus 78.4 and by 9.8 meter per second square. That will give us 4 seconds. When we often, even if these steps were questions were not there, that how long does it take the stone to reach the bottom, but you will be asked directly how far the base of the feet does the stone hit the ground. You will still need to like calculate the t first, otherwise you can't go to the b option, like b question, that at how much, like how far from the cliff it hit the ground. So x will be vx, like we need to calculate this thing and we assume that it only due to that horizontal velocity. So that will be 5 meter per second into 4 seconds, that will be 2 meter per second. The c component will be the what are the horizontal and vertical components. So acceleration is in this way. The only acceleration is the gravity. So the gravity works in the y direction. So Vx will not change because there is no acceleration in x direction. So Vx will be remains and Vx will be Vx dash. What will be the Vy dash? That will be Vy plus gt. It is 0, z is 9.8 into 4 seconds, that is 39 meter per second. This is the this is the speed of the stone after like just before it hit the ground. So this is basically step by step questions. Lucy and her friend are at an assembly plant when toy giraffes at the, at the end of the line. The giraffes go horizontally off the edge of a conveyor belt and fell into a box below. If the box is 0.6 meter, the level of conveyor belt away. Must be the horizontal velocity of graphs as they conveyor belt. So they are making giraffes. So the at the end of the line of the conveyor belt, the giraffe go horizontally off the edge. So like this is the conveyor belt. At the end of the belt, this is giraffe somehow. Just imagine giraffe. So it goes off horizontally of the edge and fall into a box here, which is 0.6 meter below the conveyor belt and 0.4 meter away. So what must be the horizontal velocity, that Vx, when it is leaving the conveyor belt? Okay, so have like box, basically this is x, this is y is given. So y basically Vy initially plus half of gt square. So here giraffe, the toy basically has the horizontal component, no vertical component. Is I, so this will be 0. and the gravity is working in that way. Can basically you can put minus in here to denote that gravity is working in negative direction, but when the zero is going in the downwards, so don't calculate y from this ground to point of zero. That will give you a positive y, but y should be calculated from the up. So this is basically minus y. So t will basically 2y by g. Okay, so this is the time, and you have 2 into 0.6 meter by 9.8, or you can have it there. So you have the t, then you need the value x. So x is Vix into t. So you need to obtain Vix only. So this is basically x by t. So x is 0.4 and this is 2 into 0.6 by 9.8. So this is 1.1 meter per second. There is many things in the question like conveyor belt and giraffe and all those things, a box, but basically it's a projectile motion question. So the x and y is given, you need to calculate vxy, and we know that x will be vxit. So basically we know x, we need to obtain vxi, so we want to know t, so t can be obtained from this calculation. So we need to do that. It's only two equation problem. The next question. The next question is the same type of question like the last one. So basically, the whole question is basically there is a cook in a ice cream parlor, which when his ice cream making is finished, he will like throw the ice cream at a speed of 2.1 meter second, 2 meter per second to the server, and the server catch the ice cream from this away from 7 centimeter. So we have to like this seven that 7 centimeter is the x direction. We need to calculate that how far do they fall. Fall means in the y direction. So we need to know the y. So the 2 meter per second, it is basically horizontal force. There is no vertical force. So this will be half of g e square. We need to know the t. Then again, x is equal to vxt. So v is equal to x by vx, half of 9.8. X is given 7. Vx is 2 meter 7 centimeters. So that is that square. So that 7 by 100. So this is basically half of 9.8. You can put minus sign. Minus sign means in the negative y direction. Basically, that will give you 0.006 minus meter or 0.60 centimeter. So the basically the cook is so calculative that ice cream doesn't fall in the ground. That's the thing. Only 0.6 centimeter when it is 0.7. It is 7 centimeters. The servers are 7 centimeters away. The horizontal, no, sorry, the vertical distance covered only 0.6 centimeter. So ice cream doesn't fall. Question is a player kicks ball from ground level and velocity of 27 meters second, 30-degree angle above the horizontal find the ball's hang time. That means the flight time. Basically, how long the ball was in like sky, the maximum height and the horizontal distance ball covered. basically this angle is 30 degree. So let us remember that at the highest point of the projectile there is no Vy. So till now the problems we are discussing, they were half projectile. And at this point, the maximum point there is only Vx. Exactly, there will be no Vy. But here, if the projectile was thrown at like a angle and with a velocity v, so the Vx will be V sin cos 30 degree, and Vy will be V sin 30 degree. Okay. So when it lands, it is at ground, so no y direction movement. So we can it hit the ground, y is equal to 0 basically. So y is vyt minus half of gt square. So it's basically 2vy by a when t not equal to 0. So Vy is 2V sine 30 degree by G. Meters, 27 meters per second sine 30 degree by 9.8 meters second square. When you put the value of sine 30 and calculate this on the calculator, it will be 2.8 seconds. So the first question is solved. What is the ball's hang time? The ball's maximum height. So y now have find the t. So that will be Vy minus half of gt square. So basically we obtain the value of t from the same equation, but at that time when the ball hit the ground, the y was 0, but this is 2.8 meter per second. The highest point the ball reached at 2.28 by 2, that 1.4 seconds. So we need to calculate the height, or to obtain the height we need to know the y-axis displacement at half of the time of the hang time. So that will be V sine 30 degree minus half of 9.8 into 1.4 whole square. V is 27. If you put all those things, it will be 9.3 meter. The value of t 1.4, we will get the highest or highest displacement in x y direction. T sine 30 degree into t minus. And the last question is the horizontal distance the ball travels before hitting the ground. Basically, this thing x. So phi x will be v cos 30 degree, and there is no acceleration in its direction. So throughout the journey, Vx will be the same. So x will be Vxt, that is V cos 30 degree into t. Here it was asked that how far it has traveled in a horizontal direction before it hit the ground. So we need to consider t as the whole hanging time period. So that would be 2.8 seconds. This is 27 cos 30 degree into 2.8 seconds. So this will give us 65 meter. So the ball flew to 65 meter away and the highest was 9.3 meter. Now, few complicated question, that is, a rock is thrown high cliff with an initial velocity of 7 meter per second at an angle 53.0 degree above the horizontal. Find its velocity when hits the ground. So basically, a rock is thrown from the high cliff and with the angle 53 degree. So it has an x direction and y direction. So in x direction, that is v cos 53 degree, that is 7 into cos 53 degree, that is 4.2 meter per second. And vxf will be the same because there is no acceleration in x direction. So that will be the same. The initial velocity in y direction was we can take 3 degree. Per second, and here the information is there is h or s, which is 50 meter. The velocity was v and the angle was 53 degrees. So to know vyf, we need to use this equation minus 2gs. So g is in negative, Fn is negative, so basically it states positive. to 9.8 into S is 50 meter. VYI we know 5.59, that will give us 32 meter per second. So the final velocity is Vxf whole square plus Vyf whole square. So xf is 4.2 whole square plus 32 whole square. And that will give us that is 32.27 meter per second. And we also need the direction. The direction will be, we know, theta, that is V tan inverse Vy by Vx, that is almost 82 degree from the horizontal. Should go to some rocket problem. So let us discuss at least one rocket problem. Is gravity free space along a straight path when its pilot decides to accelerate forward. He turns on the thrusters and burned fuel is ejected at a constant rate of basically 200 kg per second at a speed of 2.5 into 10 square meter per second. This is relative to the rocket. Basically, this is v. The initial mass of the spacecraft and its unburned fuel is into 10 to the power 4 kgs, and the question 1 is, what is the question B was, what is the spacecraft acceleration as a function of time? C is, what is the spacecraft's acceleration at t is equal to 0, 15, 30, and 35 seconds. Basically, if we can obtain this thing, C is easy to obtain. So basically, action velocity two point 5 into 10 to the power square meter per second. On the aircraft is equal to the rate of change of momentum of fuel. The momentum of ejected fuel is basically velocity and mass. And the force, we know F is equal to dp by dt. dt is m into v. V is constant here, so dm by dt. Here we know what is the dm. dm is 200 kg per second. So this is basically second into kg per second. So basically 5 into 10 to the power 4 Newton. Thrust on the spacecraft. Now we need to know the acceleration as a function of time. So we know acceleration is basically force by mass. Here there is total mass, mass of rocket, and mass of fuel. So mass of fuel is like, this is a function of t because the fuel gets ejected from the thing. Mass of rocket is like constant. So we suppose that at t is equal to 0, that was mf0 minus dm by dt. So basically A is F m r plus m f naught minus dm dt. This thing is constant, so we can write it f m I minus dm dt. Basically, A is a function of t is 5 into 10 to the power 4. So total mass was 2 into 10 to the power 4 kg minus 2 into 10 to the power 2 kg per second into t. Now to obtain, we have to like the spacecraft acceleration at t is equal to 0, 15, 30 and 35. So put t is equal to 0, so we'll get acceleration at 0, so that will be 2.5 per second square. For t is equal to 15 second, a 15 is equal to be 5 into 10 to the power 4, 2 into 10 to the power 4 minus 2 into 10 square into 15. So that will be 2.9 meter per second square. Then t is equal to 30 seconds. So that will be 3.6 meter per second square. T is equal to 35. With 3.84 meter per second square. So you can see that at a with time, like it get accelerated, and with time the velocity increases exponentially. So that's how rocket works. So this is for all today. Thank you.